So we've talked a lot about things now, and so what I'm going to talk about now is how to do the user evaluation. So you can imagine you've built the prototype, and now you really want to see if it really works. And so evaluation is really concerned about gathering data about the usability of the design or product or system by a specific group of people for a particular activity within a specific environment or work context. And you can kind of break that down into several things. So first of all, gathering data that really informs the design process, but the participants themselves are very important. So you have to think about what is your particular group of users, what activity they're engaged in, and what environment do they normally work in. There's also a question about when to evaluate. Some people think it's really good to do a user evaluation once the system's been built. And so the pros of that is that you can have a fast development cycle, maybe a small evaluation cost. But the cons of that is that if you have to fix anything and you've built a fully working system, it's very expensive to go back and fix anything. Another way to do it is through design and development. So rather than wait until the end, do evaluation all the way along. And this means you can find and fix problems quicker, but it also means you've got a longer development cycle and the evaluation costs can be higher. So one way is like this: you do the design, you do the prototyping, then evaluation, and then you probably do a redesign. Another way is like this, where you do some design and then you test it and redesign and test it again, and then some implementation. And this is what we did with the City View AR applications. Once we've even got the first paper sketches, we could show those to people and get some feedback. So in my opinion, it's always good to do evaluation throughout the whole interaction design cycle. And there's four different ways of doing evaluation. One is quick and dirty, formal usability studies, in the field studies, and predictive evaluation. Quick and dirty is really about grabbing somebody and saying, hey, do you have time to look at this for a minute? And then they get informal feedback. So if you made your first sketch, then grab your friend and sit down and say, hey, does this look like a good idea to you? So it's very, very quick. And the emphasis is on fast input. Usability testing is more formal and where people do formal tasks and you measure their errors or performance times. And oftentimes that's done in a laboratory setting. So here's some examples of lab-based settings. And then you can also do in the field or ethnographic studies. So, especially if you're using mobile AR, for example, it's really good to take it outdoors and get people to try it out in a natural setting. And this oftentimes gives an idea of what it's going to be like to use the technology in an actual use case. And then the final type of evaluation is predictive evaluation. This is where experts can apply their knowledge of typical users and find usability problems. And the advantage of this is that you really don't need to have many people. You can get 3 or 4 experts to look at your user interface and say, oh, well, the button's too small, or you can't read the text in VR. So it can be very quick and inexpensive because you don't need to recruit a large number of people of users. And these experts typically use well-known heuristics or theoretical models to do that. So here's the different characteristics. Usability testing is about doing the task. Predictive testing doesn't involve users at all. And then the types of feedback you get as well. So I want to talk mostly about usability testing because this is the one that most of you will probably be doing. And that generally starts with pilot testing, where you do a pilot small study to make sure you've got your evaluation correct. And this allows you to iron out all the problems before you do the main study. So the design of a controlled experiment should consider a number of different things like the hypothesis, what type of subjects you're going to get, the variables you're going to measure, what methods you're going to use, and how you're going to collect the data. The subjects are super important because you want to make sure the subjects you choose are representing the expected population. So for example, if you're designing a VR experience for elderly people, you don't want to test it with teenagers because they're not the target population. So you consider things such as their age group and education, and also you should have enough people to actually get some statistically significant results, like at least 10 or 20 users. And then for all your evaluation, you should have a hypothesis, so where you kind of predict what you think the experiment's going to be, the outcome's going to be, and then you manipulate and measure different variables. And there's two types of variables. Your independent variables that are manipulated to create different experimental conditions. So for example, if you've got a menu in VR, the number of items in the menu or the color of the items, that's the independent variable. And the dependent variable is a variable that's measured that's impacted by the independent variables. So for example, if you've got a menu, the number of items in the menu is the independent variable, but as the menu gets longer and longer and longer, it's going to take more time to select from the menu. So that's the dependent variable. And when you have to decide what type of experiment you're going to do, and there's generally two main types of experiments, between groups and within groups. So between groups means that each person does one condition in the experiment. Within groups means that each subject does all the conditions. So here's an example. You can see the between groups on the left. You take the subjects, you randomly assign them to 1, 2, or 3 conditions. You collect the data and then do a data analysis at the end. Whereas with the within groups, you take the subjects and then each subject does those 3 conditions, but the ordering is changed as well. And then, of course, you have to do some data collection. And the data types you collect generally can be either qualitative or quantitative, so subject or object data. So subject data is like surveys or think aloud. Objective is performance measures like time or accuracy, or if you've got a video of a person doing the task, you may count how many times they do certain things in the video. So here's an example of a good example of a VR experiment. This is from a Kai 2017 paper, and the basic idea was that to think about if you've got a Google Cardboard display or some head-mounted display, navigation is very difficult because you don't really have many input options. So their idea was to use the head tilt to provide a simulated joystick tilt, so a joystick input. So as you tilt your head up and down, it moves you through VR. So it seems like a very nice idea. This is how they implemented. They calculated the head tilt angle, and then when the head tilt angle was bigger than the gravity angle, so that little alpha there got very big, then you'd move forward in the direction that you're looking. And when you tilt your head back, you would stop moving. And then they also had to only use head tilt when walking was detected. So they could look at the accelerometer, the IMU in the phone, and detect when people were walking. So they implemented this in Unity and in Google Cardboard. Here's a video of it working. So here's the person looking down and moving. In this case, they're not. They don't have the walking implemented. They're always moving when they look down. But then they had the other condition, which was using the IMU. So now here's the IMU, and as they're walking or running and tilting down, they move as well. Okay. So they had really 3 conditions. They wanted to compare the head tilt to using a real joystick. So they had tilt head tilt with the tilt only, and then they had the walk in place and head tilt. So as you walked and tilted, you moved, and then they had the joystick only. So they wanted to compare those 3 conditions and then look at the performance time and also how many obstacles you hit while you're walking around. So that's the quantitative measures. The qualitative measures were the simulated sickness. You're in VR, you probably get sick, and also user preferences. And so they did a within subjects design. So all subjects had all 3 conditions. For each conditions, they navigated through different virtual corridors. At the end, you measured your sickness survey, and they also had scores for efficiency and accuracy, and they interviewed subjects. And this is what the performance data looked like. It's not really important to remember this, but just so you get an idea, what they found was there was a significant difference between subjects, and the tilt was faster and more accurate than walking in place and tilting and using the joystick. And there was no significant difference in sickness. And then also in terms of user preference, people generally, there was a significant difference between the tilt and walking in place for all the measures, and for learnability and immersion, there was a difference between the tilt and the joystick. You can see on the far right hand side, the joystick is low, and the immersion using the tilt and walking in place is high. So that generally led to some discussion saying that the tilt was fastest because people didn't have to walk, but it's not ideal for VR applications because the user has to look around. And when they look around, they start moving. The walking in place was a bit more slower, but people felt more immersed due to the walking input as well. And so it overall showed that head tilt could be a viable input. So that's a very nice application. I'll show you a second evaluation, a bit more complicated. So this is an experiment we did ourselves, and this is looking at communication cues. So measuring task performance and measuring user preference is very easy, but there are some richer cues you can capture or measures you can use. In this case, we had people collaborating between AR and VR, and we wanted to look at the impact of having a view frustum. So you could see on slides C, D, and E, this virtual cone comes out of people's head. And the theory was that if we have a virtual cone coming over your head, then we know where you're looking without seeing your face. And so that may have a better impact on a performance that uses gaze to do the task. So we had four conditions, sorry. A baseline condition where there was just the heads of people showing, a field of view condition where you saw the view frustum, then another one we had the view frustum and a head gaze, and another one we had the view frustum and an eye gaze. So the goal of the task was to find blocks together, and then when you found the block and communicated together, you would solve a puzzle. And so there were two phases. One was identifying the block. So one person had numbers on their block, the other person had letters, and you had to say, well, we're looking for block A3, and one person would say, here's the A block, and the other person would say, here's the 3 block, and if they were the same, then they could select them. So there was the identification task, and when they found the block, they had to pick it up and move it to an object, to a location. So it was a placement task. So here's a video of it working. So you can see this is the AR view. In the AR views, you can see the person in VR as a pink head in front of them with these green lines coming out of their face. Then here's the VR view, and again you can see the other person with the pink lines coming out of their face. And the key was that using that view frustum, I could see where the person was looking, even when I couldn't see their face. So that was what we want to check out. And unlike the other experiment, we used a wide variety of measures. So we observed how many hand gestures people made. We looked at their rate of mutual gaze, the physical movement people did, and social presence surveys and interviews as well. So a wide range of measures. Here's the data we collected. Here's some of the results. You don't need to remember that. But the overall idea was that if you look at the far bottom picture, you can see that with the baseline, this is the number of pointing gestures in blue people made. You can see when we added the view frustum, the FOV, the eye gaze, head gaze, that has gone down by almost 1/3. So that shows that once you can know where the person's looking, because you can see the view frustum, they don't need to point so much anymore. We also looked at their overall movement as well, and then here's some high-level results. Basically, we found that having the view frustum cues really didn't change the performance, but it did change a lot the communication and the impact on communication cues like the gestures as well. So some of the key lessons learned about experiment design is that you really need to decide on the type of experiment you're doing. You want to look at using a mixture of qualitative and quantitative measures. Know that your statistics, you should train the people on the task before they do the task, otherwise you have a learning effect. And then observe user behavior in a few subjects. But there's also an opportunity to move beyond surveys, and there's now a number of devices that have richer sensors in them. So you can now, and we'll talk about that in a minute, you can now buy VR headsets that have EEG sensors built in to measure brain activity or heart rate sensors. So that means you can measure all these physiological cues. So that means you can gather a wide range of richer data than just using performance time. You can also and this allows you to move data capture from after the experiment, so doing surveys, to during the experiment and measure process measures. So that's very, very important. There's also a lot better analysis tools that will allow you to do things like analyzing people's conversations or their speech and gestures together as well. And that means now we can map data to emotional understanding or cognitive load or other factors as well. And that really leads us to more about the research. So we'll talk about that now. So that's the end of the evaluation section. I'm going to turn the time now back to Joaquim, and we're pretty much right on schedule, and he's going to now talk about some research directions. And Joaquim, if there's some slides on that you don't understand, I'm happy to take over as well, and then we'll have about 10 or 15 minutes at the end for questions also.